So, welcome to all the students once again in Mathematical Logic lecture number 8. In lecture number 7, we studied the following things. We saw logical equivalence of statement patterns. We saw logical equivalence of statement patterns. And we solved problems on those. Then we studied the negation of compound statements. So in negation of compound statements, we had studied following negations, that is negation of conjunction. In negation of conjunction, what we saw, if I have conjunction of two statements, say I have P and Q, and I have to find negation. So it is equal to negation of P and Q is equal to, wait, I will use some other color because this color is not very bright. So let me use this color. Yeah. So negation of P and Q is equivalent to negation of P or negation of Q. Okay. Then we studied negation of disjunction. So negation of disjunction of two statements is negation P and negation Q. Negation P and negation Q. What we do, we distribute the negation sign for both of these statements. And if it is conjunction, we write disjunction. If it is disjunction, we write conjunction. These two laws, we had also named them as, these two laws are known as De Morgan's law. They are also known as De Morgan's law, these two laws. Then we studied negation of implication. So in implication statement, you understand if P then Q, if P then Q, negation. Negation of if P then Q is P and not Q. Remember, what is negation of P implies Q? It is P and not Q. Then finally, we had negation of P if and only if Q. Negation of P if and only if Q. So negation of P if and only if Q is P and not Q, or Q and not P. Q and not P. Okay. So for this, what trick had I suggested? I had suggested you the trick that if you want to remember the negation of, if you want to remember the negation of if P, negation of P if and only if Q, you should first remember the negation of if P then Q, because P if and only if Q is nothing but, P if and only if Q is nothing but P implies Q and Q implies P. It is double implication. It is double implication. So here P implies Q and Q is also implies P. So when you have to write the negation of this, when you have to write the negation of this, what happens is you are writing negation of this. You are writing negation of this. Now you know this is here conjunction. You understand that here you have got conjunction. What is that? See, you have conjunction of P implies Q and Q implies P. You have conjunction of this and this. Now you know when you write the negation of conjunction, first of all, you will get here disjunction. So see here, you got disjunction. Then you will also get negation of this. What is negation of this? Negation of P implies Q is P and not Q. Negation of Q implies P is Q and not P. So this we had done in last lecture. this much today. We will solve few problems on negation of compound statements. Before we start solving problems, let's have a small discussion, that is negation of negation. Negation of a negation statement. Now this is as such very simple. It can be understood without having taught, but still I shall cover this. Now you all know, students, P is, if P is a simple statement or a compound or a component statement, if P is a simple statement, then negation of P is or negation of P will have truth value opposite to the truth value of P. What we wrote here? We wrote that P is a simple statement. So what will happen? Negation P will have truth value. Negation P will have truth value opposite to the truth value of P. Whatever truth value P has, negation P will have opposite truth value. So that we can learn from the truth table. Okay, so let me have here a truth table, and what I do is I write here P, I write here negation P. Okay, so here I write P. Suppose P is true. If P is true, then negation of P will be false. Negation of P will be false. If P is true, then negation of P will be false. And if P is false, then negation of P will be true. Now what we will do is we are writing negation of negation statement. So what I am doing in the third column is I shall write negation of negation P. I'm writing negation of this. I'm writing negation of negation. Okay. So see what will happen. Now you have to write negation of negation P. So negation P is false. So what will be negation of false? It will be true. And what will be negation of true? It will be false. Now what I want you all to notice is these two columns. Look at this column and this column. What you notice? You notice that negation of negation P is same as P. So what we understand? We understand that negation of negation P is equivalent to P. So when you write negation of a negation, you come to the original statement. When you write negation of a negation statement, you come to the original statement. Yeah, hello students. Here, when we wrote negation of negation P, so the negation of false will be true and negation of true will be false. So I said false, but I wrote here true. So please make it sure that the column number 1 and column number 3 show you the same entries. So you understand that negation of negation P is same as P, which I had already written. So there was a correction here. That was an error. I said F, but I wrote P, which I corrected. Now let's solve few problems. Here we have You can see I have already written problem for you, and it is using the rules of negation. Now, what are the rules of negation? These are the rules of negation. See, these all here we have written, they are the rules of negation. So you have to use these rules of negation and write the negation of the following. So what we are given are few statement patterns. We are given few statement patterns, or you can say we are given some compound statements. Either of them can be said, and we have to write the negation of these compound statements. So I begin with, we will solve all these problems. So let's start with the first one. Okay, so the first one is, I write negation of, see here, negation of, I make a big bracket, P implies R and Q. Now you understand, students, that here I have got here conjunction of these two. I have got here conjunction of these two, and outside I have negation. See, I have to write negation of this, right? So what is negation of conjunction? Negation of conjunction is it is disjunction of their negations. Remember, when you are writing negation of conjunction, ultimately it will become disjunction. So here you will have negation of P implies R, or negation of Q. It will be negation of P implies R, or negation of Q. The next step is, now you have to write negation of P implies R. The rule of negation of P implies R says that it is P and negation R. What it will be? It will be P, negation of P implies R is P and negation R, or negation Q as it is. So this is answer for the first one. See, we wrote the answer for the first one. Now we go for the second solution. So I write the answer for the second one. See here, the second one is, we have to write negation of this. Okay, so I write here negation of, I make a big bracket, and it is negation P or Q implies R. Okay, so what I notice that here I have got implication statement. See, I have this implying R. Okay, so the first is I have to write the negation of an implication statement. Now you all know what is negation of, what is negation of P implies Q. Negation of P implies Q is P and not Q. So if negation of P implies Q is P and not Q, negation of this implies this will be this and not R. This and not R. Okay, I hope you all understand this. So here I have negation P or Q and not R. That is negation R. Okay. So further what we will have, so the, as such, you know, we are done with it. So if you want, you can just write, you can just simplify ahead. So it will, you have here negation of P or Q. Now this negation here which you see, this negation, it was already in the question. So you can leave it like this, or you want, you can simplify. So negation of P or Q. P or Q will be negation P and negation Q and negation R. So this is the final answer. This is the final answer. So now we have the third one. We will write the answer for the third one. The third is this. Okay, we have to write negation of this one. It looks quite big. Let's see how challenging this one is. So we have to write negation of, I make the bracket, inside the bracket I write the whole given compound statement, which is negation P and Q, negation P and Q, and negation Q or negation R. So in the beginning, what I notice is that I have to write negation of conjunction of two statements. See, I notice it is conjunction of two statements. Okay, so what will that be? We know that negation of conjunction is actually going to give us the disjunction of negations. So I will have negation of this, and this will become disjunction. This will become disjunction here. So I will have negation of negation P and Q, or negation of negation Q or negation R. Okay, then next step, once again, here what I notice that here I have negation of conjunction. Here I have once again negation of conjunction, and this side I see that I have negation of disjunction. Okay, so once again, I will go for that. And which law do we call this as? Whenever we write negation of conjunction or disjunction, it was named as De Morgan's law. So here, I write negation of this, I write negation of this, and this conjunction will become disjunction. Same way, here I write negation of this, I write negation of this, and this disjunction will get converted into conjunction. So what will I have here? See, I completed. So I have negation of negation P or negation Q, and then already disjunction is there. Then here I have negation of negation Q and negation of negation R. So this get me negation of negation P is P, or negation Q, or here I have Q and R. This is the final answer that we get. Here we have few more practice problems. The question goes as follows. With the proper justification, state the negation of each of the following. So there are three compound statements. We have to write negation of each one of them, and we also have to give the proper justification. Now, what is meaning of giving proper justification? That I will explain you while solving. So from these three, I'll do one thing. I will solve the second one. I solve the second one. So let me write the answer for the second one. So here I have the second. So I write the negation of this statement. I have to write negation of this statement. So negation of, I write a big bracket, and it is P double implication Q, or negation Q implies negation R. So what I notice that in the beginning, I understand that I have to write negation of disjunction of two statements. So I will go step by step. So first I write negation of disjunction of two statements. So it will be negation of this, negation of P double implication Q, and here negation of, you write negation of this, and conjunction, disjunction becomes conjunction. Negation of negation Q implies negation R. Okay, and what is my justification here? What is the justification? The justification here I write is negation of disjunction. What did I apply? I applied negation of disjunction. Okay, this is my justification. Then I go ahead and see here what I notice. I notice in the next step, I notice that I've got here double implication, and I have to write negation of double implication. What more I notice? I notice that I have got implication, and I have to write negation of implication. Okay, so see, I write the negation of double implication. Now I know the law for negation of double implication. Uh, or double implication statement is actually conjunction of two implications. So the negation will be disjunction. Okay. So see here, what do I write? I write here P, I write here negation of P double implication Q is P and not Q, or Q and not P, or Q and not P. Okay, then I have here conjunction, and here I have to write negation of implication. What is negation of implication? Very simple. Negation of negation, I will write here negation of P implies Q. P implies Q is P and not Q. It is P and not Q. Okay, so here if I have negation of this implies negation R, so it will be this and negation of negation R. So I will have negation Q. Nothing happens to this. You write this as it is. Nothing happens to this. You write this as it is. This and negation of negation R. So what is next step you get? You get P and negation Q, or Q and negation P. Okay, here I forgot to write the justification. The justification here will be negation of implication and double implication and double implication and double implication. This is what I write here. And then here I have here conjunction negation Q and negation. Okay, so here, students, yeah, please, I want you all to focus here. Here we had negation of, negation of implication. So it will be negation Q and negation of negation R. So it is actually negation R here. Okay, so what will I get? I shall get here negation of negation R will be R. Okay, as I had explained, negation of P implies Q is P and not Q. So negation of this negation Q implies negation R will be negation Q and not of negation R. So not of negation R is what? R. So this is the final answer that we have here. This is the final answer. So after completing the problems on negation of compound statements, now I take you to another very important topic, and which is quantifiers and quantified statements. Quantifiers and quantified statements. So we are going to learn what are quantifiers. We are going to learn what are quantifiers, and we will also learn what are quantified statements. Okay, so let's begin. So in the beginning, I write here x plus 4 is equal to 7. Now students, if I ask you, is this a mathematical statement? Is this a mathematical statement? So your answer has to be no. The answer for this is no. It is not a mathematical statement. Why? The reason for this, I know you must be knowing. If you do not know it, I tell you. X plus 4 equals to 7 is not a mathematical statement because I do not know whether it is true or it is false. I do not know. And remember, if I cannot say the truth value of a statement, if I am not able to say the truth value of a statement, I cannot say it is a statement. For example, if I say 2 plus 3 is equal to 7, if my question is this a statement, mathematical statement? So the answer is yes. Yes, it is a mathematical statement. Why? Why? Because the truth value is false. I know, I know 2 plus 3 is 5. What is given? 7. It means I know that this is false. So it is a mathematical statement. It is a mathematical statement whose truth value is false, that is F. So what is important, my dear students? It is important for getting a mathematical statement, it is important that you should be able to say the truth value. Now, why am I not able to know the truth value of this equation, that is this statement? Why am I not able to say that? Because of this x. Mind it, because of this x. This x is a variable. This x is an unknown. What happens is, if x is 3, if x is equal to 3, then 3 plus 4 is equal to 7. 3 plus 4 is equal to 7. And what I understand, that it is true. If x is 3, then the statement is true. If x is 3, then 3 plus 4 is 7, and statement is true. But think, if x is not equal to 3, if x is not equal to 3, x is any number but not 3. Suppose x is 7. Okay, if x is not 3, then can some number other than 3, if I add to 4, give me 7? No. Then x plus 4 is equal to 7, okay, is false. It is false. So what is happening? What is happening, students? I understand that if x is 3, then this is true. If x is not 3, then it is not true, it is false. And I'm not sure, we are not sure, we do not know what x is. And since we are not sure, whether it is true, it is false, we cannot say it is a mathematical statement. So this is, okay, is not a mathematical statement. It is not a mathematical statement. Is not a mathematical statement. Such statements are known as open statements. They are known as open statements. What is it known as? It is an open statement. It is an open statement. Open statement. Why we call this as an open statement? Because it can be true or it can be false. It can be either of them. If x is 3, then it is true. If x is not 3, then it is false. So since it is open-ended, since it can be true, it can be false, so it is an open statement. I hope you have followed this much. I just taught you what is an open statement. So here we have the definition of open statement. So an open statement is a statement whose truth value cannot be determined. We are not able to determine the truth value of a statement, and its truth value depends on the value of a variable present in the statement. When I am given a statement where I cannot determine it's true or it's false, and I understand that in the statement there is a variable which is deciding, the value of that variable will decide whether the given statement will be true or will be false, then such a statement is an open statement. For example, here x plus 4 is 7. The value of x in x plus 4 equals to 7, the value of x will determine whether x plus 4 equals to 7 is true or it is false. We cannot be sure about the truth value of x plus 4 equals to 7. See, I cannot say it's true, it's false. And you know, this is the most important condition for a mathematical statement. You have to know the truth value. If you cannot know the truth value, it cannot be a mathematical statement. Students, now we move to quantifiers. Now I teach you quantifiers. Let me write few statement here. So here I write a statement. I want you all to be very attentive. I write every student in this school is naughty. Every student in this school is naughty. Now, student, in this statement, look at the word every. Look at the word every. The moment I say every student in this school is naughty, it gives you some clear sense. It gives you some idea. What I mean all students, every student in this school is naughty. It can also be written as all students, all students in this school are naughty. The moment I say all, it gives you some clear sense, some clear picture. I'm talking about every, I'm talking about all, I'm considering each and every. So the word all, the word every, it is known as universal quantifier. What are these known as? Every or the word all. These two words are known as universal quantifiers. They are universal quantifiers. The word quantifiers is coming from, it's an adjective, universal quantifiers. The word quantifier is an adjective and it comes from quantify. To quantify is a verb. It is a verb. You understand the meaning of to quantify. To quantify is to put to quantity. To put to quantity. That is some. See the word some, little, many, too many, nothing, These words are nothing but you are quantifying. If I say some, it means I'm giving idea about the quantity. I'm saying little. Little means less. Less. Many. Many means more. So these words are giving us the idea about quantifiers, quantifying. Okay, so these two words, remember students, universal quantifiers, every and all, they are known as universal quantifiers. Okay, now remember, I wrote every student, this is my first example I gave you. I wrote every student in this school is naughty, or I said all students in this school are naughty. Now, when I say this, suddenly you come across one student. You come across one student. One student strikes your mind, and you know that he is not naughty. He is very obedient. He is obedient. He is innocent. Okay, there is one student, say for example, you know this student, you know this student. Okay, and you know that this student in this school, okay, which school? The school I am talking about. So now you know that this school, this student is very obedient. Okay, and you know that this school, this student is innocent. So when you know that this student, for example, his name is mr Mr. S, Master S, okay? So he is S. So when you know that S is not naughty, you know that he is an obedient and innocent student. So what will you say? You will say something like this. See, you will say, there exist, there, there exist, there exists one student who is who is not who is not naughty, who is not naughty. There exists one student who is not naughty, who doesn't do any mischief. He is very obedient, innocent. So now here this word, the word there exist, there exist, this word is known as existential quantifier. What is this known as? The there exist. The group of these two words is known as existential quantifiers. It is known as existential quantifier. Existential quantifier. So two types of quantifiers you have here. One is universal quantifier and the other is existential quantifier. Let me correct the spelling. It is existential, EIAL. So there exist. When you say every, when you say all, that means you are counting each and every in that community, in that collection, all. And when you say there exists, you mean at least one. There exists means at least one. So you said here there exists one student who is not naughty, who is not naughty. So two types of quantifiers we just saw here. One is all, every, which are universal quantifiers, and the other is there exist, which is existential quantifier. Let's have one more example here and see the examples which I'm writing here. These examples are for the sake of understanding only, so please do not do not mind it. So here the example I'm taking is all doctors, all doctors are hardworking. All doctors are hardworking. Now, what does this mean? I am making a statement for the whole community, for the whole collection of doctors. I'm saying all doctors are hardworking. Then suddenly you come to know about Mr. D. You know this doctor, you know he is in your locality, and you know that this doctor is very lazy. He is not hardworking. He doesn't open, his clinic time is 9 a.m. to 1 p.m. but he will always come at 11 a.m. He will always come at 11 a.m. He is 2 hours late. He is 2 hours late. And even after coming, he will not be very punctual in his work. He is not hardworking. He is sluggish. He is lazy. So the moment you come to know about this doctor, you think of this doctor. Now you understand that this statement, you contradict this statement. How do you contradict? You will say there exist, you will say there exist. Now see, you are saying there exists a doctor, a doctor who is not hardworking. There exists a doctor who is not hardworking. Now when you say this, see, not necessarily he is the only doctor, not necessarily he is the only doctor who is not hardworking. There can be many other doctors who are not hardworking. But by saying this, what are you doing is you are negating, you are writing the negation of above statement. You are just trying to contradict this statement, because here it was said all doctors are hardworking. You are putting a contradiction to this. Here it is said all doctors are hardworking. You said no, 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 there exists a doctor, because you know at least this doctor is not hardworking. So here what do you call this as? All is universal quantifier, and there exists is an existential quantifier. Now we are going to write these two quantifiers using mathematical notation. So first I will write universal quantifier. I will write universal quantifier using the mathematical notation. So what are the universal quantifiers? Universal quantifiers are when I write for all, for all, for every. These words are universal quantifiers: for all, for every. And what is the symbolic notation? The symbolic notation is this. Please remember, the symbolic notation is here. This is the way you write for all. For all. Then we have existential quantifier. The mathematical notation for existential quantifier. Existential quantifier. The symbolic notation, how do we write existential quantifier? In words, it is there exist. There exist. This is existential quantifier, and the symbolic notation is this. Okay, it looks like E, but it is reversed E, reversed. Okay, so here you have existential quantifier. So here we wrote the symbolic representation for, this is the symbol for universal quantifier, and this is the symbol for existential quantifier. This is the end of lecture number, this is the end for lecture number 8, and we will continue from the same, we will continue from the same where we are ending up here in lecture number 9. Thank you.